This variant on problem 516 deals with the topic of standard addition. The problem states vitamin C was measured by an electrochemical method in a 50.0 milliliter sample of orange juice. A detector signal of 3.41 microamps was observed. A standard addition of 2.00 milliliters of 1.72 times 10 to the negative 2 molar vitamin C increased the signal to 4.42 microamps. Find the concentration of vitamin C in the juice. The equation for 2-point standard addition is shown here. In this equation, Xi is the original concentration of the analyte, in this case, the original vitamin C concentration in the orange juice before spiking. Xf is the concentration of analyte, or vitamin C, after the solution is diluted by the spike. It does not include analyte added during spike. Sf is the final concentration of the spike after it is diluted into the original solution. Ix is the signal before spiking, and Is plus X is the signal after spiking. So we said Xi is the original concentration of the analyte, in this case the original vitamin C concentration in the orange juice before spiking. This value is unknown. This is what we are trying to determine, the concentration of vitamin C in the orange juice before any spiking occurs. Xf is the concentration of the analyte, vitamin C, after the solution is diluted by the spike. It does not include analyte added during the spike. Therefore, Xf is equal to Xi times a dilution factor, V0 divided by Vf. Into this equation, we then insert the original volume of the sample of orange juice, 50.0 milliliters. And then we insert the final volume after the spike is added, 52.0 milliliters. Sf is the final concentration of the spike after it is diluted into the original solution. So this is calculated in a similar way with a dilution factor. In this case, we know Si, the initial concentration of the spike, as 0.0172 molar. We then multiply by the dilution factor. The original volume of the spike was 2.00 milliliters, and the final volume, after the spike is added to the original solution, is 2 plus 50, or 52.0 milliliters. Therefore, Sf, or the final concentration just of the spike, is 0.0006615 molar. So we refer back to the original equation for standard addition, and we would now like to insert what we know. Xi is still our unknown, but we now have this dilution factor to calculate Xf. So in the denominator, on the left side, we have Xi times 50 divided by 52, plus the final spike concentration, 0.0006615 molar. On the right side, we insert the detector signal before the spike was added, 3.41 microamps in the numerator, and after the spike was added, 4.42 microamps in the denominator. In order to solve for Xi, we cross-multiply. We will temporarily ignore the units and also convert Xi to X for simplicity. Once we cross-multiply, we have 4.42x is equal to 3.41 times the denominator on the left side, 50 divided by 52 times x plus 0.0006615. This becomes 3.279x plus 0.00256 on the right side. when we subtract 3.279x from 4.42x from the left side, we find that 1.141x is equal to 0.002256 through algebra. Therefore, x is equal to 0.001977. Thus, the original vitamin C concentration in the orange juice was 1.98 times 10 to the negative 3 moles per liter with the correct number of significant figures applied.